So my project was on the science of glow sticks, and the hypothesis I'm testing is that glow sticks last longer in the cold but glow brighter in the warm. So here I'm taking apart a glow stick to explain the inside and how the reaction happens. So you'll see when I cut this open that there's a glass tube inside the glow stick which contains a solution of diphenyl oxalate, which is mixed with a fluorescent dye which gives the glow stick its color, and coated around the outside of the glass tubes and also in the gaps between the glass tubes is hydrogen peroxide, and the reaction of those is what creates the glow. So here I have these little popsicle tubes which are both filled with a tiny bit of hydrogen peroxide, and here I'm cutting open the glass tube of a glow stick that's been sitting at room temperature. So these were actually very hard to work with. It did not work very easily. I had to cut it a few times and just dab it in there, and even then it took a long time to get the glow. So I finally got that glow from the room temperature glow stick, and you see it's very hard to get out, and it's very small amount of liquid that's in one glow stick. So here I'm doing the same thing with a glow stick that's been sitting in the refrigerator for a few hours, and I was very surprised. Immediately it was so much easier to get the reaction, and it glue brighter than the one that was sitting at room temperature, as you can see here. The cold one is on the left and the room temperature one is on the right. So because that was so difficult, I did something else. So right here I'm cracking 5 white glow sticks that have been sitting in the refrigerator for a while, and now I'm cracking 5 white glow sticks that have been in room temperature. So you can immediately see the room temperature is a lot brighter than the ones that have been sitting in the cold, and that is not what I expected. So I got bored waiting for the glow sticks to see which one would run out. So here I have a little glass thing full of water, and I'm cutting open a glow stick. And we're just gonna see what happens when I combine the glow stick and the water. So once again, it was very hard to get out. It took multiple cuts, as you can see. I had to cut this glow stick many times and try to empty all of the little parts rather than trying to empty the entire glow stick at the same time, making a big mess of my kitchen, and just cutting this glow stick over and over again until I got a decent amount of glow stick fluid into this cup of water. So the observation here is that it doesn't mix with the water. It's almost like oil. Oil and water don't mix, and it's just kind of clumping at the bottom. So dish soap is known to mix things that normally wouldn't mix, such as water and oil. So I tried that. I tried to add some dish soap in this reaction, and it didn't do what I expected it to do at all. So I added some dish soap and I stirred it up a little, and you can see that it becomes brighter rather than mixing. It doesn't mix completely with the water, but I found that it mixed more with itself, the glow fluid did, and so now it's like, instead of having little bubbles of glow fluid mixed in with the water, it's kind of all one thing. But you can still see that it's sitting at the bottom of the water rather than mixing in with it. But I thought it was really interesting that the dish soap made the glow fluid brighter. So now I have a red glow stick. The point here is just to play around with it and to see if the colors would mix, because red and blue normally make purple. So once again, this was very hard to do, and I realized halfway through that maybe there's like a vacuum or something, so I cut the other end of the glow stick and it suddenly started working a lot better. Don't mind getting glow fluid all over my kitchen and all over my floor, but I'm just now adding some red glow fluid to the mixture of blue water and dish soap that I already had, and I'm stirring it up, and it gradually became more pink, more purple, which I thought was really cool. It's mixing. The colors are mixing as you would expect paint to mix, and I just thought that was really cool. And while the colors are mixing, I feel like it's also getting a lot brighter, and that might be because I already added the dish soap or the temperature of the water or something. I used warm water, not cold water, so that might have something to do with it. But as you can see, it's clearly mixing. The two colors don't pull each other apart. They don't stay apart. They actually mix together, and they're creating this glowing purple, which I thought was really fun. But you could still see here that it's not mixing with the water. It's still clumped at the bottom. So I added more dish soap just to see what would happen. Mixed it up a little bit with a piece of glow stick, and it did the same thing I expected it to do as with the blue. So back to the original hypothesis. This is about a day later. I have the warm glow sticks on the top and the cold glow sticks on the bottom. It was a lot easier to see outside in the dark, but the camera wouldn't pick it up because it was so dim. But the warm glow sticks on the top were still a brighter glow, but they were, I'd say, spotty. And it was starting to fade that way. But the cold glow sticks was more thorough, more consistent throughout the glow stick, but it was a lot more dull than the warm glow sticks.